Hi, my name is Andrew Seg with Megger, and what I'd like to talk to you today about is how do you determine what current clamp to select for your recording. There are many different types of current clamps out on the market today. Some of those types include the split core CT, the flexible current clamp, as well as the Hall effect current clamp. The split core current clamp is like a transformer. The current in the primary, in this case the wire that the CT is around, induces a magnetic field in the core, which is then transferred to the secondary, inducing a proportional current in the secondary. The split core CT is a passive CT with a high permeability core. It's the changing magnetic field that induces the changing current in it. This type of current clamp can be only used to measure AC current. As the name would suggest, the split core CT splits. This allows it to go around the wire that has to be tested. Now, the split core CT can have two different types of outputs. It can either have a current output or a voltage output. The split core CTs used with the Megger line of power quality instrumentation has a voltage output from 0 to 1 volt. The Rogowski coil, or flexible CT, is capable of being mounted around much larger cables and bus bars. The Rogowski coil current clamp consists of a wire wound around an air core. These are low permeability current clamps. The magnetic field produced by the conductor that this is measuring induces a voltage across the current clamp. This voltage has to be integrated over time in order to accurately represent the current being measured. Since the signals require integration, this means the Rogowski coils require power. So many Rogowski coils require batteries to operate. The Megger line of power quality analyzers will power the Megger line of flexible CTs, so ours require no batteries. Rogowski coils do not have iron cores that can saturate. So, by alternating the gain stages, we can create CTs that have multiple ranges. The Megger line of MPQ2000 flexible current clamp come in 4 ranges. They support 60 amp, 600 amp, 3000 amp, and 6000 amp. And the Megger line of power quality analyzers will automatically identify what range the CT is in. Now, the advantage of having a current clamp that does not have an iron core is it cannot saturate. The disadvantage of having a CT that does not have an iron core is that you can have increased inaccuracies when measuring low levels of current. Both the split core CT and the flexible Rogowski coil only measure AC current. It is the change in the alternating field that induces the current in them. Now, DC, direct current, does not have an alternating field. So neither the split core nor the flexible CT can measure DC current. If you need to measure DC current, you'll need to use a Hall effect CT. The Hall effect sensor varies its output in response to the magnetic field. This does not have to be a changing magnetic field, so the Hall effect sensor can measure both DC current and AC current. Hall effect sensors do have circuitry in them, so they do require power, so Hall effect sensors are battery operated. Okay, so now we've seen our different types of current clamps. Now the question is, how do I know which one to pick for the application? Well, here's several steps to follow. First, you have to take the inner diameter of the CT into account. First and foremost, the CT has to be able to fit around what you want to measure. Step 2, is your application going to be indoor or outdoor? If your application's outdoor, not only does the unit need to be weatherproof, but the CT has to be weatherproof as well. Step 3, are you measuring AC or DC? If you're measuring DC, you need to use a Hall effect sensor. And in that case, you have to ask yourself, do I have fresh batteries in it? If your CT requires batteries, you always want to make sure they have fresh batteries before you start the recording. Step 4, what's the approximate range of current you're going to be measuring throughout your test? You want to select the proper range on your CT to match this. If you select a range that's too low, you run the risk of saturating the core or clipping the signal. If you select a range that's too high, you may have increased inaccuracies on the low level of current. Step 5. What is the voltage on the line you're going to be putting the CT around? You want to make sure that the CT is rated for that voltage level and the insulation provides proper protection. Another thing to keep in mind is if you're taking a measurement in a substation on the secondary of a substation CT, take note of the bandwidth of that substation CT. Typically, these have limited bandwidths, which means they can cause inaccuracies if you're attempting to do a harmonic analysis. So this is something to keep in mind if you want to do harmonic studies in substation environments. So remember, selecting the proper current clamp can be critical to performing a good power quality analysis. What we're going to discuss today is the methods of powering the unit when you're in the field with it. The MPQ2000 can be powered either off the phase A input, or it can be powered off a standard 115, 230 volt, 50 or 60 hertz outlet.